Wooden houses are amazing because you want your house to not flex much when you have all your friends over for a dinner party. So you put in lots of extra bracing in your house so that when you put all your friends in the house, it doesn't flex so much that you have to fix all the cracked plaster. Then when the earthquake comes along, you've got a structure that's strong and lightweight, very resilient in earthquakes. The earlier houses do have a known deficit, which is the connection between the upper part of the house and the foundation. And sometimes you get the impression, people say, oh, I could never afford to make an earthquake-proof building. Houses are very close, but probably the most earthquake-proof buildings I've seen are 7-Eleven stores. The way they build those buildings is they use hollow concrete blocks and then they put steel in the hollow parts and then fill the voids with concrete. So you end up with a solid concrete wall. They've been on top of some of the most violent shaking we've seen in earthquakes, and you just don't find any damage to the structures. If you want to make a building really tall, they go the opposite direction and they make it very flexible so that when you move the base, then it sends a wave up and down the building, and it turns out that limits the forces in the elements of the building. Flexible buildings are great unless you have a really big earthquake and you move the base too much, then the columns get out of vertical and now the weight of the building wants to cause it to collapse. And Caltech's really been at the lead of trying to understand what big earthquakes will do to tall buildings.